Hi, I'm Marc Koska. I'm delighted to welcome you to this series of videos that are going to look at innovation, manufacturing, and how we can help develop the world of safer and more accessible injections for all. This is going to be a very interesting series using people inside and outside the ApiJect group, and I'm sure you're going to enjoy these conversations.
Well, I was the lucky son born with a silver syringe in my mouth.
Rajiv, thanks for spending a bit of time with us. I guess the first question is, who are you and how did you get involved with it's no secret, it's a family business, of course, but was it always in your blood to join from the age of 6, or did you take some convincing by your dad?
Well, I was the lucky son born with a silver syringe in my mouth. So,
Right, that's it. Cut. We got it.
pretty much it was family business. So I would say from childhood, it was ingrained in my DNA. And later on, when I joined from glass, we moved to disposable syringes. Or when the products were being made, pretty much I would be sleeping with a syringe in my pocket.
Tell me, I've never asked you this, but do you remember the first time? What's your first memory of being in the factory? Because glass is quite an impression, with the heat and flame and everything. What was your first memory?
Yeah, my first memory for the glass syringes, it's a difficult product, the most difficult product we ever made. So the tubes come from Germany, and then they are cut through gas flame cutters. They go to a semi-automatic machine, which is like a walking conveyor. And each station has got a burner, and they got tools which will form the glass slowly and bring it into shape. So the barrel will be pressed into a shape to give the tip, and another stopper will create the flange. And after that, it'll go to a furnace, because all the heat shocks have to be slowly to be removed. So you have to anneal that. Yeah, you have to anneal the glass. And then it'll go to another machine where it'll be shrunk. So there'll be mandrels on which it'll be shrunk onto the mandrel. And then you have an accuracy of plus minus 1 micron from the diameter from inside. And then again, you have to anneal that tubing over there. So you have to plan the shrinkages post annealing, work backwards into the mandrel to get the right. And the color of the flame, how blue, how orange, how red, all has an impact on the accuracy of the syringes.
And the clarity of the glass, I guess, as well.
The clarity of the glass, not an issue.
No.
Yeah, but then the plungers are formed the same way, and the plungers then are ground. And you've got centralized grinders which grind the plunger around, and again down to plus minus 1 micron. And every plunger is then checked. Every barrel is checked onto an air gauge to see whether it's in the right tolerance, because these are not batch produced. So you buy a syringe now, you buy a syringe 20 years back. In a hospital, it's all being mixed up in an autoclave, washed, cleaned, and being assembled randomly. So you buy a syringe now, or you buy a 5 years back syringe. The plunger 5 years back must fit on the current syringe. No blockage, no leakage, no jamming.
Yeah.
So very difficult product to make. So after that, everything was been pretty much easy.
So, but back to your first impression, do you remember the first time you saw this chaos? And, to you, it must, as a young lad, it must have been quite an amazing sight.
Yes, indeed. But for me, I think more interesting than when a machine is running, it looks very simple. So for me, the most interesting thing was going back to the correspondence, and I went to the correspondence when the machines were bought before I was born. And then I went to the correspondence when they came in from Italy, and they had to be set up. And that time, we couldn't have the Italian engineers coming in to set up the machines. So my uncle and the other people on the shop floor, they had to assemble the machine by themselves. They had to put each stopper and each flame without knowing which one goes where. And by trial and error, get to the right positioning. There was no way to teach them about the colors of the flame or how intense the heat used to be.
What year was this?
This was 19 57, 59, we started with the Japanese technology. 62, I would say. Yeah. Yeah, I was born.
And was there any plastic syringes being made in 62
No.
somewhere else?
Yes. So plastic disposable syringes came about the same time in Europe and USA with people like Hindustan, I would say.
But you wanted to, obviously, glass, there was a market for glass because you could clean it, I presume, and sterilize it. And so in a country like India, you would go for something that was more permanent.
Yeah, so wash, clean, it's a very strong vacuum delivery system. If you clean it properly, it works very well, very safe.
Yeah.
But of course, it's not so convenient like disposable syringes.
Well, it's easy to say if you clean it properly, but cleaning becomes its own skill set, doesn't it? Yeah. And when was the transition to get slowed down with glass? And that was your dad still running the company when that decision was made?
Yes, very much so. So I had just joined the company, and we had started another factory to make glass syringes for UNICEF supplies for vaccination, purely focused on that kind of syringe sizes. And then there was another factory making disposable syringes in the country, close to us. And we were watching them. We wanted them to succeed. And we were waiting for them to reach...
Let them go first.
Yeah, we wanted them to reach the 100,000 pieces mark per day, because only then it would be worthwhile to have automation and invest in that technology. No point making a few thousand syringes. So once they reached, I would say, some level of production, that's when we went over to Taiwan and shopped around for molds and machines and set up the production lines. But it was, I would say, very rapid increase. And we didn't have capital in the real sense. So started with a very small production clean room with hardly a capacity of 15,000 pieces per day to be expanded to 50,000 pieces per day. But before we achieved 15,000, we were planning for 50. And then before we achieved 50, we were planning for 100. Before we achieved 100, we were planning for 300. And then we realized we had to go for automation because there was only so many syringes you could manually assemble over there.
Yeah.
On the tabletop. And it's a long way we've come from now. That
was it literally one of those long tables with ladies or young guys sitting in a long line? Yeah. I've been in a few in China like that I guess still exist to some degree without automation. So you mentioned no capital or, restricted capital. That, I guess, made you stronger because you had to make fewer mistakes because you couldn't take those big gambles. You had to learn as you went along. Looking
back, it's amusing, but yes, that time it was quite a challenge to buy even a machine from Germany to print, say, around 2,000 pieces per hour was a big achievement for us. That level of technology, screen printed product, that kind of automation. And now we'll laugh at it because right now we'll be printing at 500 pieces a minute. Yeah. What were some of the cul-de-sacs that you went down? Oh, the biggest one was when we started making the syringes, we decided to go for the big leap in innovation. So normally, natural rubber is the product which is used to make the rubber piston in the syringe. And we decided that we will go for thermoplastic elastomer. So we went for EVA, completely new polymer at that period of time. We were quite ambitious, heard about EVA. It realizes soft material, similar like rubber kind of properties. So we made the initial mold of the rubber piston to be from EVA. And in the factory, it worked fine. The problem came that the first few syringes I had taken and given to a friend of mine, a doctor friend of mine, to try out. And he used that syringe on another friend of mine. And the damn thing leaked. We looked closely, the piston had shrunk. So it could not withstand the compression inside the barrel. Yeah. So that was, it set back the whole project by another 6 months' time. We had to go back to rubber pistons and redo the whole project from the rubber piston angle. And EVA, I guess you were looking for something that was cleaner than the traditional rubber. It had its advantages. And then later on, it took us many decades to come back again to the plastic thermoplastic elastomer-based pistons as an alternative to rubber pistons. But yes, meanwhile, the polymer technology has changed, the molding technology has changed, and the design of the component itself has changed so that you can design the component without having that risk of shrinkages and leakages.
It's quite an interesting, just thinking back at sitting here with you, it's quite an interesting scene because glass is chaotic and dirty and hot and, it looks very random, the whole process.
Yeah, you're sweating all the time.
Sweating all the time. And then you move to injection molding, but there's still dirty components in that because, I'm sure the first time you printed, there was ink all over the place and, chaos reigns. Making a black rubber stopper was always seen as an incredibly dirty process and often done outside of, the area. And so now you've seen this whole process move into this very regulated, highly advanced, clean process. And you've lived through that whole transition, haven't you? Or you've run the company during that whole transition from, that incredibly dirty, random, but very accurate finished product. Was the glass involve a lot of rejects at that time when you were hand finishing them?
Yes, so the wastages which we're having in glass syringes typically were in the 6 to 8% range.
Wow.
Whereas what we have in the plastic syringes is 0.02% range.
Yeah.
And in the needles, we have wastages of about 1.5-1.8% range.
I'm glad you mentioned needles. Needles for me that's, as you know, it's my favorite part of the whole process. So how has that technology changed? Because obviously there's some leaders in the field who are making machines that make needles more efficiently and better. And I know that they're custom made. You choose the angles, you choose the surface finish of your needle as a proprietary, trade secret almost. How's that development been overseen by you? How have you seen it go from A to B?
When we started making the syringes, we were buying the rubber components from outside and the needles from outside. And the initial cannulas, the needle points, which we were buying from outside, one day I bought a magnification glass 20x and I saw the needle through that. And I was horrified. I said, this is what we are selling. It had steel burrs and metal shavings all inside the needle and around the edge.
Inside the tube?
Inside the tube.
Yeah.
I said, no wonder it's so painful. People were complaining that our needles are very painful compared to Japanese and American needles. And that's where I started looking at the points very closely through a magnification glass myself personally. And I compared that to Japanese needles and I found very precise, accurate edges and consistent angles and shapes inside. You can't see that with the naked eye, but yes, on the magnification, you can see that. That's when I realized that we were completely off track. We should not be buying needles from India. So I went over to Japan and met the right people, shopped around and managed to get the technology to make the complete product in-house. So to make the needle points in India and also the tubing later on in India. And high precision engineering, yes, and then mass production, very much so.
That in itself is a journey because it's a charm offensive, if you know that phrase. Because when you go to Japan and you say, hey, I want to buy all your, some machines, they're like, no, thanks. We're going to keep all the secrets ourselves because there's a lot of secrets in the processing and the finished goods in this. And even though it's such a simple product, there's hundreds of tricks and know-how steps that you have to learn along the way. And knowing you, I know that you could probably buy a machine from anyone that you set your target on. So now you're in a different position because you're one of the biggest syringe producers in the world. So you're a very valuable customer to most of these people. Again, what were was any horror stories on that journey where you flew somewhere? And I know some others where you've flown to Europe, but anywhere you've flown somewhere expecting to buy a machine and then you met with the the hand and were told no?
Oh, yes, very much so. So in the beginning, it was like that. But I managed to reach out to the president of the company through the trading companies, and then I made my pitch that I will not be their competitor. I will not sell to Japan. I will not initially sell outside of India. I'll not be selling needles and cannulas per se. I'll just be selling the syringes with the needles. And it was in their interest to see a company in India succeed, because if we would not succeed in India, somebody else would make in India. And then that company, whoever makes in India, would become so strong and powerful with that big market space to disturb the market dynamics in Asia. And that would hurt in the long term the Japanese manufacturers themselves. They saw some logic in my reasoning, and then I was able to convince them that they can trust us. We'll be fair business people. And we moved on from there. So over the years, the credibility that we built up allowed them to introduce us downstream to their suppliers and their material suppliers and their machine suppliers. So it's been many years of relationship building. So I would say sometimes I have a more close relationship with my suppliers and than I have with my customers.
What's the relationship between the human interaction and the innovative side of the business? Because obviously you need both. You need to say, this is my future vision. How do I create it? But then also you've got to get these suppliers on board, and you've got to get colleagues to agree.
Yes.
So
there are two parts
there's
to
obviously an interesting
There are two parts to
interplay.
it. Yeah, the two parts to it. So one part is the marketing part. To market a Me Too product, vanilla product, what's the story? It has to be different. So there has to be some innovation, either in packaging, in presentation, in combination. So before we came into the market, the syringes were sold separately and needles were sold separately. The syringes were packed in blister packs. So we gave to the market a syringe and needle combination as pre-assembled. We gave to the market the syringes and needles coming in a ribbon pack, which was a tougher, more robust packaging for the Indian conditions, dusty and dirty conditions in transportation.
Just to pick up on that, because some of the packaging has a paper layer which can get stained with dust or water. And you've moved, in the most part, to a cellophane, if that's the right word, package all the way around, almost like food packaging, because it can be wiped clean and doesn't stain.
And again, when you go deeper inside the process, ear on the ground kind of a thing. So the syringes were being transported from one city to another city in gunny bags. We would ship them in boxes. But our distributors...
Gunny bags, like a cloth sack? Or?
Yeah, so jute bags.
Oh, a jute bag, right.
So they would take out the syringes from the boxes and they would transfer them to these gunny bags, because then they could smuggle them across the borders, because one province would be having a different tax from the other one. So they would be going in through carts and tractors. And it had to be very robust packaging to survive all that. So the package should not get punctured on the way. And that's where we realized that, yes, we had these advantages available, which our competition did not have. And anybody who had to compete with us had to come to our kind of specification and to compete with us on our terms. So those were the innovations in terms of packaging, then in product. So again, in terms of product, we had to talk to our suppliers to give us something different, not just be a simple a Me Too product, so that anybody coming and copying us would be having some pain factor. So they're small things, but yes, they do make a difference.
And obviously, you've got, it's fascinating when I visited you, the sales and distribution system that India has, which is probably quite unique, actually, as a marketplace.
My company's, we got more than 9,000 dealers. And
you don't employ any of them?
No, these are independent business people.
These are all independent,
Yeah, these are all independent business people. And they become our extended sales force because they do it for commercial profits. For them, success of the product is directly attached to the purse.
I remember you organized that I could go to the market in Old Delhi and see how they break up a box and how they distribute it, and they sell in smaller volumes and then larger volumes. And it's
crazy because I could not understand myself. It's like what they don't teach you at Harvard Business School. So they were making more money from selling the shipping cartons than they were selling the syringes.
Unbelievable. Incredible.
It's so competitive.
Yeah. It's like going on a trading floor that you see at one of the stock markets.
Yeah.
The
I
way
still wonder, how can they price it so low? Where are they making the money? Are they stealing the syringes? Are they giving less syringes in the box? And so competitive. But yes, practically making money from the boxes.
It's amazing. And also the streets are, because they stayed in the original market, the streets are just a few feet wide and people are squeezing through with these boxes. And
not only that, the shops are hardly 100 square feet. So they can't even hold a truckload or a small truckload of syringes.
So where is the stock? Is it in trucks around the market?
That's where the interesting part is. So whatever they're buying in the morning, before they close shop and they leave, they must sell it because they don't have a place to keep it. So they may buy it and sell it at zero profit.
Prices are very flexible.
Very flexible as long as the inventory is moving. So as long as the inventory is moving out, so they will be having no place to even put a chair. They'll be sitting on the box. And that's the reality.
And they make good money, those guys?
Yeah, until now it's like that.
Yeah, it is. I mean, it's a brilliant
But with
experience.
the new taxation system, of course, they can now afford bigger warehouses and they don't need to do all this cross-border smuggling and stuff like that.
Yeah. So finally, let's end off on sort of the topic of the day, environmental. What have you done and what are you planning for the future to sort of meet the environmental standards that everyone's now expecting?
Yes, so we do have an ESG policy in the company. So in terms of that, we've reduced the plastic or the weight of the plastic and what goes into the syringe by weight and by volume into the product. And when we made this, the most recent product that we've now recently launched is called Disposable or the Kojak Smart Syringe, which basically is a disposable syringe or auto-disable syringe, which has got a safety needle on top. And the designs which you typically will see in the market, whether it's in USA or in Europe, the size of the safety needle is pretty much the same size as a small 2 ml syringe in terms of pack size.
Yeah, it's
and
sort of complex. That long. Yeah.
So it's got normally 4 to 6 components, plastics. So what we did in that innovative design was to keep it as the standard 3-component needle. No extra cover, just the cover was redesigned to be a safety cover. And the size of the pack pretty much is nearly the same as of a hypodermic needle, which is currently. And it's like 1/3 the size and less than 1/3 the weight of a safety needle that's available in the market. Now imagine the kind of volumes that will be saving in the container loads. So if a container load has got about 1 million of our syringes, from the competition will be about hardly 300,000 syringes, which goes into a container.
Right.
So 3 times the shipping, 3 times the transportation, all that is multiplies. So engineering innovation plays a big role in making sure.
Yeah.
And closer to the process level, so we used to be using water for the air conditioning and for the molds, for the chilling and everything. All that has stopped. We use now only air-cooled chillers, no water. Nearly every factory of ours now is like 0 water discharge. So whatever water is being used in the toilets or whatever, some processes or something like that, that's all being kind of recycled, and we've got our own sewage treatment plants to recycle everything.
Amazing. Good. Well, I look forward to my next visit, and thanks for joining me today.
Welcome. Thanks.